Umanosaurus was a small short-necked plesiosaur, about 2 meters long, that lived in the polar shallow seas covering much of what is now Australia 115 million years ago during the early Cretaceous. Its known fossil remains include a specimen nicknamed Eric, one of the most complete opalized vertebrate skeletons ever found. While most of its body was fairly generalized for a plesiosaur, its skull was unusually ornamented. A raised ridge along the middle of its snout shows evidence of supporting a larger keratinous crest, and smaller ridges over each of its eyes may have also had similar structures. These crests were fairly delicate, so were probably mainly used for visual display, and might have been brightly colored. With their short necks and large elongated heads, polycotilids resemble the pliosaurs, but closer phylogenetic studies indicate that they share many common features with the Leptocleididae and Elasmosauridae. The neck of Edgerosaurus is short for a plesiosaur, containing a total of 26 vertebrae. The neck and skull together were estimated by Druckenmiller to comprise up to 45% of the animal's length. The lower arm bones of Edgerosaurus are very short and wide. The first digit of its forelimb consists of 7 bones, the second 11, and the third 10, while the fourth and fifth bear 9. The jaws of Dolichoronchops are not thought to have had a powerful bite force, however this would be an unnecessary ability as it's the teeth that would do the work in prey capture. The teeth are long and thin, which means that they are best suited for puncturing slippery soft-bodied prey. Arranged across the long jaws and getting slightly larger towards the ends, they would have provided an extensive area for prey capture, quite similar to some ornithocarid pterosaurs that are thought to be dedicated hunters of fish. Unfortunately, while long thin teeth like Dolichoronchops possessed are great for this kind of prey capture, they are not suited for tearing prey into small pieces. Like their plesiosaur cousins, Dolichoronchops probably swallowed small prey whole, and may even have relied upon swallowing stones for use as gastroliths. These would have allowed Dolichoronchops to break down hard parts such as scales and bones. Although not as well known as its more famous relative Dolichoronchops, Trinocromarum remains one of the best represented polycotylid plesiosaurs in the fossil record. Like its relatives, it was a plesiosaur, but one with a much shorter neck and elongated jaws filled with thin needle-like teeth. Living in the western interior seaway of the late Cretaceous, Trinocromarum was a predator of fish that used speed and maneuverability to capture its prey. In turn, Trinocromarum would have likely been targeted by other predators, with possible candidates including large pliosaurs. Judging by the holotype, which is the partial remains of one single specimen, the length of a Tenbrosaurus was 4 meters long. From the skin impression found with the bones, which was later destroyed, it is presumed that the creature had membranous skin, devoid of any significantly large scales, probably for decreasing water resistances. As it approached shoals of fish, it could use its long neck to reach in and snap up a fish, the sharp teeth in the mouth granting a Tenbrosaurus a secure grip upon its prey. The skin impressions with the original fossils are noted as being a smooth membrane that was devoid of any noticeably large scales. The exact classification of Hophiosaurus can vary depending upon the source, though most researchers concede that it is almost certainly a pliosaur. Further to this, specimens of the genus are superficially similar to the Romaleosaurid pliosaurs. In fact, one former species of Macroplata, one of the best-known Romaleosaurids, has been reassigned to Hophiosaurus. Depending upon the species and specimen, it is known to have ranged from about 3.5 meters to almost 5 meters in length. With a total length of 4 meters, Pelonustes is not a large pliosaurid. It had a large, triangular skull, which occupied about a fifth of its body length. The front of the skull is elongated into a narrow rostrum. The mandibular symphysis, where the front ends of each side of the mandible fuse, is elongated in pelenusts and helps strengthen the jaw. An elevated ridge is located between the tooth rows on the mandibular symphysis. Like other plesiosaurs, it was well adapted to aquatic life, using its flippers for a method of swimming known as subaqueous flight. Pliosaurid skulls were reinforced to better withstand the stresses of feeding. The long, narrow snout of pelenusts could have been swung quickly through the water to catch fish, which it pierced with its numerous sharp teeth. For strong paddle-like limbs suggest that Liopleurodon was a powerful swimmer. Its foreflipper mode of propulsion is characteristic of all plesiosaurs. A study involving a swimming robot has demonstrated that although this form of propulsion is not especially efficient, it provides very good acceleration, a desirable trait in an ambush predator. Studies of the skull have shown that it could probably scan the water with its nostrils to ascertain the source of certain smells. Most people's first encounter with Liopleurodon was in 1999 when the BBC featured this marine reptile in its popular Walking with Dinosaurs TV series. Unfortunately, the producers depicted Liopleurodon with a grossly exaggerated length of over 25 meters, while a more accurate estimate is 6 meters. The problem seems to be that Walking with Dinosaurs extrapolated from the size of Liopleurodon's skull. As a rule, pliosaurs had very big heads compared to the rest of their bodies. Like most pliosaurs, cymolestes possessed salt-secreting glands, which would have enabled the animal to maintain salt balance and drink seawater. Recent studies on plesiosaur locomotion indicate that cymolestes, like other plesiosaurs, possessed a unique bowplan for movement, which differs from modern organisms in similar niches. Its exact feeding habits are unclear. The current consensus, however, is that the genus was primarily tithophagous, consuming belemnites, soft toothoids and ammonites. It is possible it was also ecologically separated from other contemporary pliosaur genera by hunting in deeper waters or at night, as modern cephalopods exhibit diurnal feeding cycles, spending daylight in deeper, safer waters, and rising at night to feed. Iectus specimens are known to preserve turtles and plesiosaurs as gut contents, which shows that they were prey for the large pliosaur. Large squids are also found in the area, so it has been hypothesized that they too were prey items, though there is no direct evidence for this. Aeromangosaurus bears large, round bites on the skull that may have been due to Iectus predation. The first 3 maxillary teeth are enlarged and form caniniform fangs, with 3 pairs of similar caniniform teeth in the mandible directly in front of the fang-like top teeth. The lower jaw caniniforms stop between the last pair of premaxillary teeth and the first pair of maxillary teeth. Originally described as a species of Plesiosaurus, this was the first pliosaur ever named, which is why Pliosaurus is used as the type genus of the Pliosauridae. Related to the long-necked plesiosaurs, the pliosaurs adapted to fill a range of different predatory niches, with some like Pliosaurus itself being hunters of other marine reptiles. Such prey preference is indicated by the large teeth as much as 30 centimeters long and jaws which would have been okay on small prey like fish, but devastating against large prey like plesiosaurs, ichthyosaurs, smaller pliosaurs and quite possibly giant fish such as leadsichthys. Because of its long history, a large number of remains under many different species have been attributed to the genus, but the list of valid names has now been greatly reduced as a result of more intensive study of the fossils. The earlier attribution of fossils under multiple species names is known as the wastebasket effect, and is something that happened to almost all early discovered prehistoric creatures. Gallardosaurus is one of a slowly growing number of distinctly Cuban marine reptiles that would have swum in the Mesozoic seas. However, as a marine animal, it likely had a broader distribution than just the waters of what would become Cuba. It would probably have seasonally migrated across the Caribbean Seaway, and would have preyed mostly on nectonic fish that dwelt in the region in which it existed. Also known from the Jagua vieja member are ichthyosaurs, the marine turtle Notoames and the Plesiosauroid Vinealosaurus. The water depth was shallow, perhaps 10 to 12 meters deep, and oysters and algae colonized the sea bottom. As huge as Kronosaurus was, its teeth weren't very impressive. Sure, they were each a few inches long, but they lacked the lethal cutting edges of more advanced marine reptiles. Presumably, this pliosaur compensated for its blunt teeth with a lethally powerful bite and an ability to chase prey at high speed. Once Kronosaurus got a firm grip on a plesiosaur or marine turtle, it could shake its prey silly and then crush its skull as easily as an undersea grape. The size of pliosaurs is susceptible to exaggeration, given errors in reconstruction, confusion between various genera, and sometimes the inability to distinguish between juvenile and full-grown specimens. Although Kronosaurus fossils have only been identified in Australia and Colombia, the extreme distance between these two countries points to the possibility of worldwide distribution. It's just that we haven't yet discovered specimens on any other continents. Published descriptions of Monquerosaurus estimate that it should reach a total size approaching 8 meters in length, making it a large representative of the pliosaurids. It was found in the Arcilolotas abigeratas member of the Paja Formation. This formation preserves a shore face to lower shore face environment with a great diversity of marine reptiles including elasmosaurids, protostegid and sandownid marine turtles, large-bodied teleosaurids and various ichthyosaurs including the macropredatory Kaihidasuka, which was also described in 2021. The formation is also known for its diversity in pliosaurs specifically, with 4 distinct genera being known from the region. Sakicosaurus was a large pliosaur, with the type specimen measuring approximately 10 meters long and weighing 17 tons. The holotype specimen was found in 2013 and is known from a near-complete skull, and postcranial elements including a complete hind limb and various vertebrae. Diagnostic features include a very short mandibular symphysis, reduced number of mandibular teeth, slender teeth, among other features. With a preserved length of 10 meters, the specimen is interpreted as a subadult individual. It is one of the most complete and large pliosaurid specimen. When in the water, Nothosaurus would have used a combination of its tail and its webbed feet to propel itself through the water. When not searching for food in the sea, Nothosaurus probably spent most of its time on land, although probably not so far as to lose sight of the sea. Returning to land meant that Nothosaurus would not have to spend all of its time swimming in the ocean, as well as possibly avoiding marine predators like sharks and possibly ichthyosaurs. The land may not have been totally safe, however, as archosaur reptiles may have been a threat if they were able to access the same coastal areas that Nothosaurus used. Although it lived on land, it remains uncertain if it reproduced by giving birth to live young or if it laid eggs. Fossils of Nothosaurs of other genera suggest that live birth was possible, and live birth also seems to be the norm in the ichthyosaurs as well as possibly the later plesiosaurs, which are thought to have evolved from the Nothosaurs. The problem remains, however, of exactly when live birth in marine reptiles started to occur. Sylvestrosaurus is very similar to its close relative Lariosaurus, but there are enough differences for most people to assign them to different genera. The nasal has no contact with the prefrontal, separated by processes of the frontal and maxilla, and many parts of the skull, such as the parietal and postfrontal bones, are much broader and flatter than in Lariosaurus. The clavicles do not meet in an anteromedial suture, unlike in Lariosaurus. In Sylvestrosaurus the radius is slightly longer than the ulna, but in Lariosaurus they are the same length or the radius is shorter. As the back half of the skeleton is missing, we cannot compare the number of vertebrae. Cephalopods was much more elongated than its relatives, reaching 3 meters in length, and had fully developed flippers with no trace of visible toes. It had multiple elongated phalanges, making the flippers much longer than in most other Nothosaurs, and more closely resembling those of the later Pliosaurs. It also had the shortest skull of any known Nothosaur, which further increased its resemblance to Pliosaurs. Although possessing a long neck and tail, Cephalopods may not have swum by undulating its body. Analysis of the bone structure of the hips and powerful tail suggests that it instead propelled itself through the water much like a penguin. The evidence of Pachypleurosauria in the preserved stomach of Cephalopods remains lend credence to the theory of it being a fast swimmer. While Nothosaurs in general are thought to have eaten fish, Lariusaurus is confirmed to have eaten other marine reptiles, specifically placodonts, as indicated by the remains of 2 Siamidus juveniles inside one Lariusaurus skeleton. It also seems to be a marine reptile in transition to a more aquatic life. This is because while the rear legs were still suited to land movement, the front legs had evolved to form paddles. This would be a hindrance to movement on land, but a considerable bonus when swimming in the water. Paleodraco had long slender jaws full of numerous tiny teeth, creating an interlocking comb that was probably used for filter feeding, scooping up mouthfuls of fine-grained sediment from the seafloor and filtering out small invertebrates or soft plant matter. The bones of its skeleton were also highly thickened and dense, a condition known as pachyostosis that provided ballast to weigh it down in the water. This would have made it a slow and unmaneuverable swimmer, but a very energy-efficient one, using its natural neutral buoyancy to hover or walk along the seabed. It was essentially a reptilian manatee, filling a similar sort of ecological niche. Panzersaurus was only about 40 centimeters long and is known from a single near-complete skeleton. Although it was a distant evolutionary cousin to Pliosaurs, it was actually most closely related to an early sauropterygian lineage known as the Pachypleurosauria, a group of small lizard-like aquatic reptiles with tiny heads, long necks, and paddle-like limbs. It had an unusually short and rounded-off snout compared to its relatives, and since it would have lived alongside many other diverse marine reptiles, it was probably specialized for a slightly different ecological niche. The locomotion of Kawasaki probably resembled the underwater flight that Pliosaurs employed. The flattened forelimbs would likely have acted as hydrofoils. The hind limbs show less specialization, and may therefore have acted as stabilizers and control surfaces, such as is seen in extant sea turtles. The intermediate nature of the limb morphology implies that there was also, to some extent, the kind of crawling through the water seen in small freshwater turtles. The powerfully built pectoral girdle allowed for the attachment of strong muscles, but their location beneath the shoulder favors the underwater flight model. Despite the specialization of the limbs, the tail also shows adaptations to an aquatic existence. Nothosaurosaurus would have been a relative of the more famous Nothosaurs, yet still be distinct enough to not be classed as a Nothosauran. It was originally named Pachypleurosauria, that means thick rib lizard, a reference to the thickness of the rib. Such thick ribs are uncommon in terrestrial animals, but in aquatic animals they are quite common since the greater weight helps the animal to stay under the water, rather than just bob about upon the surface. Despite this buoyancy adaptation, however, it still retained limbs and feet that would have been useful on the land. Wimengosaurus was a relatively small sauropterygian, reaching lengths of around 1 meter. It had a streamlined body, paddle-like limbs, and a long tail, characteristic of sauropterygians. As a sauropterygian, it was likely a marine reptile, feeding on fish and possibly other marine organisms. It inhabited marine environments during the Middle Triassic, likely swimming in shallow seas along coastlines. It contributes to our understanding of the diversity and evolution of sauropterygian reptiles during the Triassic period, which was a crucial time for the diversification of marine reptiles.